Okay, cool. So thank you everyone for joining. So this session is about unlocking value from your data with analytics on Azure. And so presenting to you, myself, Boris Kravtsov, and Habiba, we both work in data and AI space on Azure, Microsoft, and I'll let Habiba maybe introduce herself first, and we'll go after.
Thanks, Boris. So yes, Boris, I'm Habiba. I am a cloud solution architect working with Boris in the data and AI team here in Sydney. And my main focus is in machine learning and AI. My background is in data science, so I have been practicing machine learning and deep learning before I joined Microsoft earlier this year. So yeah, I usually help with engagements where enabling clients where on their machine learning journey. So yeah, that's me. Thanks, Boris.
Thank you. My name is Boris Kravtsov, cloud solutions architect as well. I'm a bit of a jack of all trades when it comes to data and machine learning and AI, everything all around. You can ask me any of these questions. I've been at Microsoft for a while, so I have quite a few discussions with customers under my belt on a wide range of topics and scenarios. So happy to share all that goodness with you. So don't be shy to reach out. So just to kick off, what I wanted to do is level set and really talk about the value of what value is for a startup. That's my understanding anyway. And so I think startups exist to solve a hard problem, hopefully at scale, and by doing so, add value to the customer. And so, what the startup team is bringing is the effort, hopefully with good execution and knowledge, the domain knowledge, soft skills, as well as hard skills as well. So those intersect, but you also need a way to scale, right? And so the way to scale would be to ask for capital from VC, from Microsoft, and also you could scale with the tools. You can scale with the compute. So all the stuff that Azure provides. And so we're going to be talking about some of these things in the session. So as I've been talking to customers, I see two common patterns that customers unlock to get to value. So first, it's about decision. This is like top down. It's about helping an agent to make complicated decisions, or you could automate small decisions at scale, right? As you know, making many good decisions need quality information as well. So, and this information needs to be aggregated somehow, right? So this information, by the way, is just pieces of data that are relevant. Okay, so you've got to understand that. So what you can do, you can buy information from a third party, but then you're sacrificing your defensibility, right? So you're sacrificing your moat because that third party can sell same piece of data to your competitor. So as we'll discuss later, building your own data set or aggregation is actually part of the product development loop that analytics incorporates. So you can solve another way of thinking about value creation with data and analytics is you can solve one single problem well for many customers. You could also solve many problems to many customers as well. So an example of that would be maybe Facebook and Google, where they're solving a lot of marketing decisions, automate a lot of marketing decisions for a very wide range of customers. But in order to do that, you actually need a wide, complicated data set, which they've been able to do. So, and so the reason I'm talking about it is like, how do you think about creating value for customers? Do you start with the data or do you start with the decision? And so arguably, it's easier to start with the decision and follow the normal play for iterative loop for like product development. So start with why and then do the what. So what I also wanted to talk about is what are the tools that you can use in Azure to solve the decision problem as well as the aggregation problem. So you can actually do this, solve both of these quite effectively in terms of your effort, in terms of your resources as well. So we'll map that out for you. So decision insight process, and it's designed to help you start with the decision. So that's why I was I've started here with thinking about, well, do you start with data or do you start with the decision? It's easier to go with the decision, and this is the process to follow. And it's actually very similar to your normal product development loop anyway. So there's probably nothing new in this slide. So we're just adapting that. So you start with a decision, you formulate a question, right? And that is specifically designed, I'll get to that shortly. Then you acquire your data set, you model your data, and then you produce insights. So the reason, like you start with a decision, and some of the examples are like, it's kind of like a binary thing. So ship or not ship, predictive maintenance could be at high volume, could be needs maintenance or doesn't need maintenance, things like that. Target customer, not a target customer. And so this eventually will lead to an action. So you've got to think about what action this is going to generate. Again, nothing new. You'll be thinking about that anyway when you're doing, when creating features for your customers. Now, the decision informs the question. So this is an important step, because what you don't want to do is create a feature, like create a cool feature that nobody really needs, right? So you actually want to go the other way, and this is a filter for you to first start with the decision and then you go to the question. So you're not starting with data, you're not starting bottom up going to the decision. Now, what I'll do here is probably pass it on to Habiba to talk about the process of machine learning. So Habiba, over to you.
Thanks, Boris. So before we dig deeper into how we do machine learning, first let's level set that what machine learning is, how it's defined in different places. And the thing is, at the end, there's no standard definition. It's used interchangeably, but it's good to know how we understand it. Next slide, Boris. Thank you. So usually you would hear these terms: data science, machine learning, AI, deep learning, all of these used in different places. And when you start digging into them, they seems to be quite similar to each other, or sometimes differentiated, and it gets really confusing. So just so that we understand what they are, in general, data science is this very abstract concept where you combine statistics, data analysis, as well as some business problem to solve, to make a decision. So as Boris explained, that the decision-making process. So that's where the whole data science picture comes in. Machine learning gets more technical. It's basically about letting machines learn from the data what is the outcome. So the question that you want to get answered, the machine is going to learn that answer automatically just by the data that you throw it into it, without telling it how you should map the question to the answer. And AI is this term that is used to mimic systems that to refer to systems that mimic human cognitive services. So our speech, vision, linguistic, etc., or decision making. These are something that are human human phenomena, human capabilities, and when machines are able to mimic those things, that's what we call AI. And as I said, all of these terms get used interchangeably, and I am guilty of it as well, and I will end up using it, all of these things interchangeably throughout this talk as well. Next slide.
1 second.
All right, so now before we get into, now that we've defined machine learning, the thing that we really need to address, the next thing that we need to address is that why as a startup you would need machine learning. And next slide, Boris. So the thing is that the overarching point is the data empowers everyone. So when you have data, you actually have leverage over others. And as a startup, when you are targeting a niche market, you're collecting data. Every single touch point with your customer is where you are acquiring a data that's unique, that's different, that sets you apart. But if you don't do anything with that data, you don't get any value out of it. So you you have the power, but you now need the tools to use that power, and that's where machine learning comes in. That your decisions and your insights that Boris talked about are enabled by the data that you have. So this is where you would where machine learning would be a differentiator for you. And now in the next slide, I will talk about what are the in different ways that you can leverage machine learning. So a few ways that you can where machine learning can be used can be useful for startups is one, efficiency. So there's lots of processes that you can automate. So for example, if you have a retail portal and you want to provide customer services, you can incorporate chatbots with intelligence that have linguistic understanding and are able to answer free text questions from your customer base, and are able to make the process of customer service easier for you. Similarly, sentiment analysis, startups are really always relying on how your customers are responding to you. So it really is important what reviews you are getting, how people are responding to your products. And if you have a system that can automatically analyze the sentiments of your user base and is able to tell you that how they are feeling about the product, can help you go a long way. And later on, Boris is going to give you a demo on how easily you can incorporate this thing. It sounds hard, that you would probably need to do a lot of natural language processing, but with Azure Cognitive Services, you can simply get started with sentiment analysis in a few steps. Then second, personalization. Who are your customers? Where are they located? What are their preferences? These are the kind of questions that you always have to answer so that you are maximizing your reach to the right people. Similarly, what products or what other things to recommend? You don't want your customer to stop at let's say buying one product, but should be able to you want to keep them engaged. You want them to be to stay hooked to your products. So how would you recommend them? What would be the smart way of doing that? How would you do it better than your competitors? These are all the things that you can answer with machine learning. Security is a big issue. So how do you detect spam? So who are the real users? Who are the one that you really need? Who you need to sell to? So these kind of things. Other ways of screening your customers. These are things that you can easily do with machine learning. There are like tons of methods that can be used, and there are tons of tools that can be leveraged for it. And last but not the least, marketing. So how do you know where to target your customers? Is it through some blogs? Is it through Facebook? Is it through ads on some search engine? What makes how do you differentiate yourself? These are all the kind of things that in marketing that you have to answer. And as a startup who is just targeted on a niche market, you really need to focus on these things a lot more than a well-established established organization that has a brand name backing, and people will just follow along with any new product that they launch. So these things are really sensitive for a startup, and these things can be answered with machine learning in a lot more better way than just by doing any kind of rule-based using a rule-based system. Next slide. All right. So now, before we dig deeper into how do you do machine learning, I want to just give an overall picture of what the whole machine learning or data science life cycle looks like, and see how I already have interchangeably used the term machine learning and data science. Anyways, so data science in general, as Boris mentioned, you start with some decision, which is your business. What are the things that you want to achieve? You start with that, and then you move on towards your data. What would be the right data for answering that question? So if you think about yourself as a startup, what you know is that you on day one, you just have a business problem that you want to solve. You don't know how you want to solve it. If you could use magic to solve it, you would probably go for it. But you usually don't have that. So you try to use other tools. So you build a website, you build an app, or whatever else. But this is how you would try to solve the problem. So in data science as well, you start with a business problem, and since it's data science, and as I said, it's a combination of your business problem, your data, and your analytics. So the second question that you need to answer is, what kind of data you need to answer that question? How are you going to get it? Can you, as Boris said, can you buy it? And if you buy it, the thing is that those companies that are selling you the data can give the same data to some other company as well. But maybe that sometimes work because the next steps, which is analytics, could be something that differentiates you. So you have the same data, but the way you are looking at it is different. So that's where you are adding value. Or otherwise, you will try to get to find your own data. So for example, you build an app, you build a website, you start engaging with the right audience and start getting the data. Once you have the data, there's a whole process of how do you explore, cleanse, featurize, et cetera, the data. Once you have that, you move on towards your to the left side, to the modeling part, where this is where the machine learning side comes in. In a whole enterprise setting, you would do the deployment as well. Where are you deploying it? Where are your audience? Do you need to deploy it on an IoT device, or is it going to be deployed as a web service, etc.? All the decisions that you make, and then you have and that's where the process ends, and you have a whole machine learning or data science tool incorporated in your startup. This is a whole process, and sometimes you don't do the whole thing, but depending on where you how far you want to go, you start building it. So it's a journey. It's not something that on day one you have a sophisticated model, but you start with data exploration, some kind of diagnostic, then do some predictive future predictive analysis, and so on. So yeah, so overall the picture looks like this. It looks very complicated, lots of pieces to take care of, but you don't have to do it all of these things on day one. I just wanted to make sure to give you the big picture here. And next slide. So now, yeah, Boris is going to talk about the data acquisition and understanding part.
Thank you, Habiba. Do not be scared. Things are not that complicated. So data acquisition and data understanding probably one of the key, most important things you will do in your activity and getting to your automated decision making. So there are a couple of steps involved in this. So data ingestion is number one, as you would expect, and then data exploration. So you check, validate your data, make sure it's all there, and then ultimately you create some sort of automated pipeline to do it all over again quickly, and that also incorporates some data engineering. So, and by the way, I will demonstrate how you could map this out into Azure services in later steps. So in data exploration, there's actually a crucial step in being able to get data ready for consumption in your analytics pipeline. So there's actually quite some skill involved in doing this. And the reason is there's lots of different pitfalls that you can encounter. Like first, you can get incomplete data that maybe has some skew or is just like missing for a particular group of like users, for instance, if you're doing some sort of prediction in retail setting. So you could have missing data. You could have missing data classes. So you can have noisy data as well, where like there could be just errors introduced due to human entering incorrectly in a call center or something like that. So you're going to have to filter for those with specific techniques. There's some outliers you can take care of, inconsistencies as well. So there could be conflicts in there. And different like relations as well. Like you want to make sure that data is consistent across the board. If you're stitching different data sets together, make sure that like, the correlation is there as well. So there are different techniques doing all of that, but do not worry. Like some of these things can actually be done automatically for you using Azure Automated Machine Learning. So if you're just starting out and you're going into the deep end, Azure can take care of the bulk of this work for you, which is very cool. So now data cleaning, I'm just going to go very quickly over this, but again, we've talked about missing values. So you've got all these different techniques available to look at missing values and replace them, potentially delete. And this is basically what a data scientist would do. Then you would normalize data. So you need to worry about things like scale, because machine learning model needs to know, well, if it's 1 to 10 here and there's 1 to 100 there, you need to normalize values for different variables, make sure they're on the same scale. Otherwise, you're going to have distortions in learning. So then you have discrete, so you have like categorical variables, right? Or like if you have true or false, how do you get true and false into a 0 and 1, something like that, right? Or categorical variable could be ethnicity. How do you encode that? So there are things like that you're going to have to worry about in data preparation. So like there's some of these things that also like basically that's feature engineering for you. Now modeling is basically what I'm getting to now. And data modeling is feature engineering. So specifically shaping your data for machine learning model to consume. And again, this is an iterative loop. So you start with data, then you create some sort of like training data set. You build the model, you evaluate the prediction, and you do it all over again, over and over until you get the prediction that is acceptable for you. So that's key. Now, how do we map this out into Azure services? It's all been conceptual, but in Azure, you can actually do a lot of these things fairly effectively. So first, in order to acquire data, so do data engineering, data integration, feature engineering, you would actually use something like Azure Synapse Analytics. And that has ability for you to ingest hundreds of different data sources in real time or in batch. Then you would actually use Azure Machine Learning. If you don't want to do feature engineering, you could use automated machine learning to do a lot of that stuff for you. And like you can even use model deployment feature within Azure ML. There's lots of different things that Habiba is probably going to show you today that's packed within Azure ML. Then once you have made the prediction, or if you need to serve your insights to the end user, you could use something like Power BI. You could also use Tableau or some other tool. But ultimately, you need to have a way of representing these data. And so you can blend your descriptive analytics, so like traditional BI, with predictive analytics, or you can even push prescriptive analytics, where you're predicting a data set and actions, you're making a decision automatically. So all of this is totally possible, and it's not hard. Now, I'm not going to spend too much time on Azure Synapse, but this is one of the key services you would use to, as you remember, aggregate data in order to get data into one single place, create some structure around it, and extract information from it. So, and by extracting information, I mean creating some sort of order around data so that it has a model that then you can consume downstream by something like your machine learning pipeline. So in Synapse, you have ability to ingest streaming data in real time, batch as well, hundreds of different connectors. All of that lands on very cheap data lake storage. And then you have ability to query that using SQL. You will have option for Apache Spark. So there's code first, no code experiences. The security is all managed. There's a governance layer around it, and there is also UI that we're going to show you. So all of that is integrated with Azure Machine Learning, as I said, also Power BI, visualization, and also data sharing, where you could share data with third parties in a very frequent, without introducing too much friction. Data sharing can be difficult too, believe it or not. Right, so what I'm going to do now is do a quick demo of sentiment analysis for you on Synapse. What I'm going to do is stop sharing and share another screen for you. Just give me a second. Okay, hopefully that works. Okay, so I brought you in. So what I'm showing you on the screen is Azure Synapse Analytics. So what we're going to be doing here is creating a sentiment score from some like feedback from a customer. So probably emails sent to a company, and so now we need to be able to detect what kind of sentiment they have, right? And probably go after the ones first, prioritize the ones that have negative sentiment. So the first thing I would do is get data to Azure. So the way I would do it is very, very simple. So this is Azure Synapse Analytics Workspace. All I need to do, like the simplest way, is just to upload the data set. So you can do it this way, just go upload button, and boom, you have your CSV file in there. So that gives you ability to preview. You've got the columns there, and you have ability to query that as well. Just really quickly, I'll show you that we have a way to very easily query the file in a SQL manner. So this is just an SQL statement that runs against this file in Azure Storage. So I'll close that off. So how do we get to sentiment? So the way you would do this is by creating a new notebook, and you create a new Spark table. So I would do that, but instead I'll just go and show you the output of it. So that generates a little bit of code. So I don't know whether you're actually familiar with Apache Spark. If you don't worry. We generate this basic code for you. So you run the statement with an Apache Spark cluster. So Apache Spark cluster is basically compute in Azure that you borrow for the duration of time you're interacting with it. So we're billing for in 1 minute interval. So when you execute this query, you're getting charged for the 2 minutes, 34 seconds. You're not spending much money. So when this is done, what you're going to get is in the in data tab, you're going to get a table. So let me go back to Workspace, and you can see we have a table. So we've ingested a CSV file, and we've created a table with different columns in it. So what we now can do is point an existing machine learning model, predict sentiment. So what we're going to do is use something called Azure Cognitive Service. So these are pre-built machine learning models that Microsoft has built that you can also customize with your data. And so in this case, we're just using off-the-shelf one for center-bit analysis. And so we're going to run this data set that we've ingested, and we're going to run it against a target column, which is comments. So if I go on Open Notebook, we'll generate a set of code that you would run against the compute that you'd select here. And so this is like, it looks complicated, but really it isn't, because like ultimately you only need to worry about these couple of lines of code where you have a select statement and you also defining what the parameters you would like to predict, right? And that's it, language, error, and so this is all. So when you run this, you get the following output is not available. So let me run this again. Hopefully this will complete in time. So again, joys of doing demo. But ultimately, if this doesn't complete in time, I'm just going to talk you through it. In a few minutes, we're going to get an output with a table with a sentiment score, predicting line, email, one, probability of a negative sentiment is 0 point something, or positive sentiment 0 point something as well. So that's basically the end of the demo. And it demonstrates how you can get data into Azure very, very easily and be able to get to the actual machine learning model and insight in literally minutes, without spending any time, without spending really any funds in order to do this. This will cost you dollars and or less. So let me stop here and reshare my screen. Do you have any questions?
I mean, hi. I would like to understand where like Databricks fits into this. Is it like an alternative to like load data in and transform it, or?
Cool, yeah. Very good question. So Databricks is a sister or brother service that Microsoft has introduced in partnership with Databricks earlier before Synapse. So Databricks is just Spark. Synapse is a lot more. And so there's a bit of a discussion around there, but if you just want to do code first, Spark, then Databricks is the way to go. Otherwise, Synapse is probably going to be the place to start. I don't know if I've answered your question though, to be honest. But let me share my screen again.
Yeah, I mean, obviously my company is using Databricks and we're trying to ingest stuff in. And when I look up like resources on like how to do things and where the data is sitting and stuff like that, it all comes up as like other Azure stuff that I can't even find in the Databricks UI.
Yeah. So what are you using Databricks for, sorry?
Basically our single source of truth system. So we're at the moment ingesting raw data into bronze. We're trying to clean it up into silver and then gold, and then expose that for like redoing all of our BI dashboards and stuff like that, and then branch off and do machine learning over on top.
Right. Yeah, Databricks is a way of doing it. Synapse is another way. It really depends on your requirements, where you want to go. I don't know how big your data set is. Typically, I would say if you've got a small data set, do not touch Databricks, go with Azure Machine Learning instead, with Synapse. You have a lot more freedom of movement there, but we can take it offline and have a discussion. Maybe let's revisit it during the Q&A at the end of the session.
Yeah, that's cool. Thanks. I just thought maybe it's slotted in there somewhere and I missed it.
No, we didn't want to confuse people.
Sure.
But it seems like it's worth discussing. Yeah. So Habiba, do you want to touch on this?
Yes. Thanks, Boris. So Boris talked about Synapse, how you get the data in quite easily and can leverage some of our pre-built services, the cognitive services such as sentiment analysis within Synapse. So and start doing machine learning. So that's one way of doing it. But now I want to step back and talk about what else do we have on the offer, and how flexible it can be. So Azure Machine Learning overall offers you services that are code centric. So you can, if you are a seasoned data scientist and like to write your own code, so you can write your own notebooks. You can use Python, R, you can use PySpark and Scala, and as well. So depending on, so you have all the flexibility that you had when you were using machine learning on your own systems. You're able to do that on cloud as well. The good part about using a cloud service like Azure is that you have a lot more. You are not stuck with any single kind of a framework or services, but you have you can use any if you want. So this gives you a lot more flexibility. Also, if you are as a startup, I would assume that it's not always you don't have the luxury of have professional data scientists in your team, and you have the data, so you still want to be able to quickly be able to get insights and value out of it. So so Azure Machine Learning provides you with low code and no code capabilities of building machine learning models as well. So basically, we have Azure Designer, which is a drag and drop tool that helps you build machine learning model by writing not a single line of code. It gives you this whole logical pipeline of building an end-to-end machine learning machine learning model. Similarly, we have AutoML that is also that you can build through that can be used through the SDK, as well as a very user-friendly interface to build massive amount your machine learning model, and that I'm going to talk about a little bit in detail. And when Boris mentioned those feature engineering, data cleansing, and data exploration part, I will demonstrate how AutoML can help you with that process. So as Boris mentioned, that they probably sound very very hard, but there are a lot of those features that are already pre-built, and you just need to know what kind of feature engineering you need, and you can get started. Similarly, at the very end, our pre-built model, Boris showed you the ones sentiment analysis in Synapse. Similarly, we have an anomaly detection as well. And now this is our overall landscape of what is the AI machine learning services on Azure. So on the top, we have these domain-specific pre-trained model that you can just use as a service. They are already trained on massive amount of data, and all you need is, given your application, you can use them. So if you're doing computer vision, you're doing some kind of object detection, you can use computer vision cognitive service, for example. Then the next step is you can write your own data science tools. As you can use any your own code as well, using any of the tools you're familiar with. So Jupyter Notebook, for example, is very common and popular with data scientists. You can use Visual Studio Code as well, Azure Notebooks, and so on, whatever your favorite tool is. Similarly, you are not limited by any framework, PyTorch, TensorFlow, Scikit-learn, Onyx, any framework that you are familiar with, comfortable with, you can use. Similarly, you have for data science, you have a whole bunch of services. So you can use machine learning as well as Azure Databricks if you want. If this is what your business problem requires, you can go for it. And similarly, at the way end, which I think as a data scientist is very useful, as that the flexibility of being able to use any kind of hardware infrastructure that's required for for a particular job. So for example, if a particular problem can be solved using just CPUs, you have those options. But if you require more computational power, you have GPUs and FPGAs as well. And this is all based on you only need to pay for when you're using it, and don't have and can spin up a compute instance for yourself for use when you need it, and then switch it off when you don't. So you don't have to invest, as a startup, don't have to invest in a hardware upfront for building any massive machine learning model. Next slide. So now within Azure Machine Learning, as I mentioned, we provide all the services from a very pro code, low code to no code services. So notebooks, if you are familiar with Python, you can write your Python code. You can use R as well. With AutoML, it helps you automate a lot of your machine learning process by helping you select the right machine learning model, the right features, the right parameters for your hyperparameters for your models, etc. So it helps facilitate the process for you. The designer on the way right is a drag and drop interface that helps you build your machine learning model without writing a single line of code. And next slide, Boris. So this is what the designer looks like. So again, yeah, you have these modules that you just simply connect with each other. So given you remember the data science lifecycle that I mentioned at the beginning, you start with the data, then second step, you start cleansing the data, you do some feature engineering, so normalization of the data, and then build models. So all of these things are modules that you can just connect with each other and build a whole machine learning pipeline. The good part is you don't have to write any code for it. And the second really powerful feature of this is that you now have a very visual way of looking at what your machine learning life cycle looks like. Next slide. And this is a typical notebook that if you have written any code anytime in any Jupyter notebook, you would be familiar with this kind of interface. You can do the same kind of things within Azure Machine Learning portal, or you can use your standard notebooks and use the Azure Machine Learning Compute at the back end. And lastly, the AutoML. Next slide, Boris. So yeah, this is, I think, one of the really cool features. And as a data scientist, I would say that, yeah, this is really something that that really resonates with me, is that as a data scientist, you typically are not, when you start with your machine learning or data science lifecycle, you don't know what methods would work. It's an iterative process, and you try lots and lots of experiments until you find the right method. Once you have the method, you do a lot of you need to figure out the right parameters, and before even that, you need to do like which features to use. So you start with the data, you have the data, but then you need to do what features you need, what algorithms would work for them, what are the different hyperparameters that would work for them. And this would be your one model, and you would do it iteratively for many more models. So keep on going, Boris. So basically 3 steps. You have your feature, you want to know which features are important for your problem, which algorithms would work, what would be the right hyperparameters. And eventually you have some model evaluation. You would do it for one, you would need to do it for any combination of your features, any algorithm, any combination of hyperparameters. And you can simply understand this as an exponentially hard problem. There's massive amount of feature that you usually have hundreds of features. You have an option of a number of algorithms, and each algorithm has a number of parameters, and it just takes weeks and weeks before you figure it out. AutoML helps you automate the process, and Boris, you can keep on going. So yeah, what AutoML will do is that would try out different features, different algorithms, and would tell you, and different hyperparameters, and tell you which model works best for you. And you pick up the one that, let's say, which has the best performance, let's say 95%, whatever that means, would be the one that you would pick up, that this is the right approach. So so basically, overall, Azure Machine Learning offers you a lot of options of how you build your machine, how you can get started with your machine learning and get started really quickly. And AutoML is one of those things that I find super useful, because it helps you try out many different approaches in just within a few minutes. So, and here I'm going to demonstrate a very simple example that, let's say you're a startup who wants to sell orange juices, and you want to be able to forecast that, what would be the demand like, and what would be the, let's say, which brand people prefer, let's say. So for that, I would use AutoML, and I will share my screen.
Very quickly, time check, so 10 minutes left.
All right, I will be super quick. Okay, sorry, wrong screen.
So while we're prepping a demo, are you guys thinking of any questions for us to ask?
So Boris, there was one question where I think Nim wanted to know what was the result of the query which you ran.
Right, yes. Let me send you a screenshot in a second. Wow, I don't want to disrupt Habiba's presentation.
Yeah, maybe just put it in the chat. I think that will be good. Thank you.
All right, can you guys see my screen?
Yep.
Okay, so this is what the Azure machine learning interface looks like. So as I mentioned, we have for authoring options from notebooks, AutoML, and Designer. And I'm just going to mention the AutoML part. So AutoML, as I mentioned, is a really, you can do it with an SDK as well as you can do it with the UI as well. And these are all the 4 steps that you need to specify. So what data you have, you just specify some configuration run, which is basically what compute you wanna, what kind of compute you would require. And then select the task. AutoML will help you even determine the task. So for example, if you are predicting a continuous value, it will tell you that it's a regression problem, or if it's a time series data, it would automatically tell you it's a forecasting problem, which is what this orange selling orange juice problem is. And of course, like if you think it's making its suggestion is not correct, you can select it as well. And also we have the validation and testing option as well, which is a little advanced, but I'm not going to touch on it. So basically, within three steps and one optional step, pretty much you have a model up and running. I'm not going to start a new run here, but we'll show you an output of the one that I have already ran. So this is an AutoML job that was run on forecasting orange juice. So basically, the data was all about that, time series data. It's a synthetic data of this grocery store called Dominick's in the US, primarily in Illinois, and they're selling different brands of orange juices. And the question is that what is the demand like in different stores? So using that data, I built I created an AutoML job which tried a whole bunch of algorithms for me. So all of these are the options that AutoML automatically tried. So these are all the algorithms. If you're a data scientist, you might be familiar with some of them. If not, you can easily read up on them. But the important part is that you didn't have to write the code for any of these things. AutoML automatically picked up all these methods for you, and it ranked them based on the performance of each of them. So right now, since it's a very synthetic data, it doesn't matter what is how it's ranking it, but it would tell you from top to bottom that what are the best algorithms, and you can further dig down into each of them and see what was the decisions made on. So for example, in this, the voting ensemble turns out to be the best method that it suggested, and you can easily see that you can dig deeper into it, that what were the features that were most relevant. So advertising was really important for forecasting the demand or price, or people with the age group of the people or the brand, etc., are the important features. So yeah, it was super quick, but the point was that with AutoML, if I was a data scientist, and if I was given this task to forecast the sales of something like orange juices, I would be spending weeks trying to find out what are the right features, what are the right algorithms, how do I tune the hyperparameters. Whereas with AutoML, all of these things are taken care of. I have the flexibility to still do things by myself. So for example, it's not that AutoML is completely taking away the control from me. I can still do it. But on the other hand, it's helping me out by suggesting me the right approaches as well. And it gives me the way to be able to do to dig into each of these models and understand them. So super helpful, and helps you get started, derive value from your data really quick and easily, and you don't have to spend a lot, spend time learning machine learning very deeply. Yeah, that's pretty much it for me. Thank you.
What I will do is share my screen as well to show you the result. So on the screen is the result of the query that we ran. So you can see the output here in the bottom. This is the sentiment analysis score. And so what we have here is the comment that we've analyzed. So you can see this, I've ordered 3 widgets. Line was very disappointing, the way they were packed, and more negative sentiment in there. So they came out mixed, neutral, and negative 0.73%. So it's pretty good. And so it goes all the way down to positive as well. So this is like the JSON that you could, JSON output that you can parse. What I failed to mention here is this capability is not just limited to sentiment analysis. You can use this approach with any of our cognitive services, which is Palantir. So you can use an out-of-the-box one again, or you can customize one. It's up to you. So in order to use these services, you do not need to be a data scientist. You just use them out of the box. So another way of thinking about it is you do not solve a problem that you're not reinventing the wheel, basically, because this has already been done at scale. Now I'm going to stop here and pass over to you, the audience, for the questions. Come on, don't be shy.
Anindya has a question.
Hi. Yeah, thanks for the presentation. It was really useful. I had a question that's kind of like specific to what we're building. So we're building a matching service for people. So like it's a recommendation system for people. So think of it like it's kind of like a generalized dating app problem. Have you ever worked on anything like that? Do you have any recommendations for algorithms or approaches? I've worked on like recommender systems before for e-commerce. So that's the only approach that I've thought of so far. But if you have any suggestions, that'd be great.
Habiba is smiling. Habiba has something in mind, but we have something to talk about as well. Go for it.
So, Anindya, yeah. First of all, I think if you're just starting on it, so probably what you'll need is some kind of a rule-based system. So it won't be machine learning, right? So it's been the beginning. You have some conceptual idea of if you're matching people, you have an idea what are the parameters based on which you want to match. But that's something that is sans machine learning. But eventually, what you need is to keep an eye on what's the outcome. So what are your criteria of knowing whether you succeeded in making a match or not? So these are I have quite similar to the matching app. I once worked on something similar. The point was that before you bring in machine learning, you need to have a very good proxy or performance metric in place so that you can figure out that how successful you are. So for example, if you're matching people, what's the criteria that do they go on a date, do they stick together, or like
we have a rating out of 5. So assume that we've got the data set already. So say we have a large enough data set, then what would we do?
So yeah, if you have the large enough data set, and then for the recommender system, one of the things you need to understand is that what's the distribution like. So basically, how does when you have a cold start problem, you have a new user that comes in, and then you want to figure out like what do you barely know anything about them. So what do you want to suggest? So you need to find what are the parameters that you would leverage to be able to recommend to find the right matches for them. So I think this becomes a really important problem to start with, to figure out like where how do you how do you do your user-based segmentation, and use that as your starting point for finding the right matches.
Habiba, do we have that set of algorithms for recommenders available publicly, the one we've looked at recently?
Yes, and I can share the link for that.
Okay, thank you very much. So we do have something that Microsoft Research has come up with. There is plenty of information there. I suggest you take a look at it. If I was looking at it, that's basically an exhaustive list of all the different approaches you can use for recommended. One-stop shop. But you do need to be quite savvy and understand what it means. So hopefully
it's open source, and you can easily, and it's a very active community, and you can use, all the code is available, and you can simply get started with the recommended system right away. I will share the link of it just now.
So for the cold start, I don't know if anyone else has any other questions, but can I ask another? For the cold start problem, like we were planning on using NLP on the BIOS and status, because that's like one of the inputs that we get. Is that something that you've done before?
I have used Bayesian approaches before. So yeah, those are the one that I'm more familiar with. So I've done it one for an online retail store problem. And for that, I use this Bayesian online probabilistic regression approach where based on historical data, we were trying to see the distribution of the customer segments and then using recommendation according to those. Okay.
So like you use like TF IDF with Bayesian or something more sophisticated than
that? I don't exactly remember that. Yeah, so don't have an answer right away that
okay.
But with NLP, you would still use some sort of rule-based system on top of it, right? To interpret those results.
I don't know, I've seen some like literature coming out on deep learning for like translation and things like that. So I was just wondering whether that would be applicable to something like this type of recommendation.
If you have a big enough data set. So the link that we've shared also has a deep learning capability there as well. So there's one implementation for deep learning. So you can give that a shot too.
Okay, awesome. Yeah. Thank you.
No worries. Anyone else? And by the way, we're happy to stay back a little if you have time. So if you have any questions, we can take that in the extended session.
I'll just check out, guys, if there's anybody who doesn't have questions right at the moment. You guys are on the Slack channel, right?
Yes. Yeah.
Okay, and I know you're not on LinkedIn, Boris, but
oh, you can reach me on LinkedIn as well. No problem at all.
Cool.
Yeah.
Well, just in case there's questions down the line, it's about sort of sowing the seed of what people might be able to do with these tools. Might not quite be on their radar yet, but if it does come up a little bit later, Habiba and Boris, if you're happy to be contacted by the fellows, maybe we could drop our email addresses in, or just contact on Slack as well if the questions aren't right here, right now.
Absolutely. So I know, Alex, you want to have a broader, deeper discussion. So if you're itching for it, yeah, definitely reach out. We can have another call.
Yeah, cool. I mean, I guess, some of the hard things as being a data scientist is like thinking of the problem or thinking of the question as you had it. So like I just started in a new job in a bank, and they're like, oh, we have no idea what data science is. We think it's this. Here's a little feature we want you to build, and I'm like, that's literally software engineering, nothing to do with data science. So how do you go about thinking about ideas or problems you can solve or questions that could be asked, I guess, because that's what chucking 10,000 models onto a data set to find the best model doesn't help if you don't have a question.
Yeah, and that's exactly right. So you're just creating more technical debt for yourself without really adding any value. Yeah.
And Ananda, if you have any questions regarding recommender system, please feel to reach out and we can have a longer discussion on that. We've been working on a few use cases lately, so we'll be happy to share any thoughts on those.
Yeah, that sounds awesome. Yeah, definitely. We'll reach out. I just saved your email.
Cool.
Thanks. All right. See you.
All right. Thanks, everyone. Thanks for your time.
Thank you so much.
Very much, guys.
Thanks so much for the session, Boris and Habiba. Thanks so
Yeah.
much,
No worries.
Sabe, for joining.
You're welcome.
Thanks, everybody. Have a great afternoon.
You too.
Bye.
Thanks.